You know, the fight against malaria is one of humanity's oldest battles. But now, we have a groundbreaking new weapon. And we're not targeting the disease itself, but the creature that spreads it, by literally rewriting its DNA. So here's the big question, and it's a wild one. Can we actually hack a mosquito to stop it from transmitting malaria? I know, it sounds like something straight out of science fiction, but as you're about to see, some incredible new research is making it a reality. But first, to really get why this new tech is such a game changer, we need to understand the scale of the problem we're up against. Even with all the progress we've made over the decades, malaria is still this devastating public health crisis. It's a really stubborn threat, and a lot of African nations in particular are struggling to knock it out for good. For years, we've relied on things like insecticide-treated bed nets and indoor spraying. And hey, they've saved countless lives, no question. But we're hitting a wall. See, mosquitoes are smart, and through sheer evolution, they're becoming resistant to our chemicals. So our best defenses are starting to fail, which means we desperately need something new, something innovative. And that brings us to the really cool part of this story, this powerful genetic tool that's designed to basically turn the mosquito against the parasite it carries. The technology is called a gene drive. So what is it? Think of it as a way to put inheritance on hyperdrive. It's a genetic tweak that makes sure a specific trait gets passed on way, way more often than it normally would, letting it spread like wildfire through a population. This slide breaks it down perfectly. Normally, passing on a gene is like a coin toss, a 50-50 chance. But a gene drive? Well, it completely rigs the coin toss. The new modified gene gets passed down not half the time, but more than 90% of the time. It's almost guaranteed to spread. Now, here's a really critical point. This approach isn't about killing off all the mosquitoes. Instead, the plan is to replace the existing population with new mosquitoes that carry this genetic trait, a trait that makes them totally unable to transmit malaria. So you're basically swapping out a dangerous population for a harmless one. So the theory is solid, right? But for this to really matter, it has to work outside of a perfect lab. It has to work in the real world, with real-world parasites, and that meant taking the science directly to the front lines. For more than 20 years, scientists have been working on genetically modifying mosquitoes. But there was always this one big catch. The research was almost always done in labs in Europe or North America, and they were using parasite strains that had been cooped up in labs for decades. And that left this giant unanswered question hanging in the air. I mean, sure, you can stop a lab-grown parasite, but what about the incredibly diverse, tough parasites that are actually out there infecting people in villages right now? Nobody knew for sure if this would work against them. So to answer that question, researchers did something amazing. They brought the lab to the problem. They actually built a state-of-the-art genetics lab inside 2 shipping containers and plopped it down right in Tanzania, putting the science directly on the front line of the malaria fight. And in this lab, for the first time ever, an African-led research team was able to engineer local Tanzanian mosquitoes. Then, they challenged them with malaria parasites taken straight from the blood of infected kids in the communities nearby. This was the ultimate real-world test. All right, so the test was on local mosquitoes, real-world parasites. The big question is, did the genetic hack actually work? The visual evidence here is just incredible. Okay, on the left, you're looking at the gut of a normal mosquito. See all those big, round, pink circles? Those are the developing malaria parasites. Now, look at the gut from the modified mosquito on the right. The parasites are tiny, they're stunted, they've been almost completely blocked. The modification was working. But stopping the parasite in the gut is only half the battle. To actually be transmitted to a person, the parasite has to grow up, break out of the gut, and then travel all the way to the mosquito's salivary glands. So the next huge question was, did any of them actually make the full journey? And the results are just staggering. In the normal mosquitoes, 55% of them had parasites in their salivary glands, meaning they were fully capable of spreading malaria. But in the modified mosquitoes, get this, that number dropped all the way down to just 7%. Let's just put that into one powerful number. The genetic modification led to an 87% reduction in the number of mosquitoes that could actually transmit the disease. That is a massive drop. It's an incredibly strong barrier against transmission. So, what does this all mean? Well, this isn't just another interesting lab result. This really represents a fundamental shift, a new hope on the path to finally getting rid of malaria. So let's break down the key takeaways. First, we now know for a fact that this technology works against the diverse, real-world parasites infecting people today. Second, this was proven in a cutting-edge lab in Africa by African scientists. And finally, all of this brings us a huge step closer to having a powerful, self-sustaining new tool in this fight. The research team really put it perfectly themselves. They said this work brings the technology a critical step closer to application, creating a tool that's not just powerful, but also tailored to the very place where it is needed the most. You know, a success like this just opens up a world of possibilities. It proves that gene drive technology isn't just some concept in a textbook. It's a practical tool with just immense potential. So if we can use it to disarm the mosquito that carries malaria, what could be next? Dengue? Zika? It's a really powerful question for the future of global health.